So good morning students, let me continue Pythagoras theorem problems. So we are in the end of Pythagoras theorem theoretical problems. So only few problems left over. So please refer to my previous videos. Next, ABC, in a triangle ABC, angle B is 90, angle B is 90 and D is the midpoint of BC. In a triangle ABC, angle B is 90. In a triangle ABC, angle B is 90. D is the midpoint of BC. So here D is the midpoint of BC. In a triangle ABC, angle B is 90. D is the midpoint of BC. D is the midpoint of. Prove that AC square is equal to. This is also very important. Prove that AC square is equal to AD square plus 3 times CD square. So question is clear. In triangle ABC, angle B is 90, right angled at B. D is the midpoint. D is the midpoint of BC. Prove that AC square is equal to AD square plus 3 times CD square. For this you need to join this. Join CD, join AD, join AD. Consider triangle ABD. Square on the hypotenuse. So here AC square they are asking. So AC square they are asking means you should consider not triangle ABD, you should consider triangle ABC. Square on the hypotenuse is equal to AC squares. Square on the hypotenuse is equal to sum of squares on the other two sides. BC square plus AB square. Now AD square is there, no? So now consider triangle ADD. Right? Now you should consider this triangle. Square on the hypotenuse. You are right here by Pythagoras theorem. Right? Square on the hypotenuse is equal to sum of squares on the other two sides. BD square plus AB square. Right? Marked by Pythagoras theorem. So subtract 1 minus 2. What you will get? AC square minus AD square is equal to this AB square will get cancelled. BC square minus BD square, right? So AC square minus AD square. See here we are nearer to the theorem. So AD square bring to that side. AD square plus BC. BC square, BC is nothing but what? BC is nothing but twice BD. BC is nothing but 2 times BD whole square minus BD square, right? So AD square, this is this one. This part AD square I transpose to that side, so it becomes AD square. So plus this is nothing but 4 BD square minus BD square. AD square 4 minus 1 is 3. 3 BD square. So there ends the solution. AD square plus 3 BD. BD is nothing but you can write here. BD is nothing but here I have written now BC. BC length how will you get? BD. BD here BC is nothing but twice of BD. Twice the length of BD. Therefore BD you can write like this, but what you have to prove? CD is there. Since BD is equal to CD, you can write AD square plus 3 times. In place of BD, you can write CD. Actually, you can left here also, but they are asking particularly this one. So, you need to write in place of BD, CD. Therefore, AD square plus 3 times BD is nothing but CD. So, 3 times CD square. Hence the theorem. Very simple problem. Next one. So are you following? Subtract 1 from 2, you will get like this. AB square, since he is asking AC square is equal to A. So that's why I have transposed AD square to that side. Now BC whole square is nothing but 2 times BD whole square. So that is nothing but 4BD square minus BD square is 3BD square. BD is nothing but CD. BD is nothing but CD. Then is the theorem. Next one. In triangle ABC, AB is greater than AC. In triangle ABC, AB is greater than AC. In triangle ABC, AB is greater than AC and AD is perpendicular to BC. AD is perpendicular to BC. Prove that AB square minus AC square. AB square minus AC square is equal to BD square minus CD square. So this is a straightforward question. There is no confusion at all. AD is perpendicular to BC given. Consider this triangle. So AB square is equal to square on the hypotenuse. Consider triangle. Consider triangle ABD, right? In triangle ABD, apply Pythagoras theorem. AB square is equal to BD square plus AD square. BD square plus AD square. Next, consider triangle ACD, this triangle. So here obviously it is 90 degrees. So both are 90. So AC square is equal to AD square. Square on the hypotenuse is equal to sum of squares on the other two sides. AD square plus CD square, right? Now subtract these two. AB square minus AC square. They are asking this one, no? Mark this as 1, mark this as 2. 1 minus 2. What you will get? AB square minus AC square is equal to, here BD square is there and this AD will get cancelled. So BD square minus CD square. So there ends the solution. Here you can write, if you want, you can write AB square AD square minus AD square. So hence it is proved. Very simple. Now another problem. This is typical one. ABCD is a parallelogram. In AC and BD are the diagonals. Prove that ABCD is a parallelogram, right? And AC and BD are its diagonals. AC and BD be its diagonal. AC and BD be its diagonal. Prove that they are asking what? AB square plus BC square plus CD square plus DA square is equal to AC square plus BD square. So they are asking this one. ABCD is a parallelogram given and AC and BD are the diagonals. Prove that they are asking this. Show that AC sum of squares of the sides is equal to sum of squares of the diagonals they are asking. So let AC and BD intersect at M. Let AC and BD intersect at M, right? From this, apply Apollonius theorem. By Apollonius theorem, APPOLON, Apollonius theorem, APPOLONIUS, Apollonius theorem. What does Apollonius theorem states? And again, what does it state? Apollonius theorem, the sum of squares of the sides of any triangle is equal to sum of squares of sides. Sum of squares of the sides of a triangle is equal to twice the square of the median plus twice the square of the side of the base. That is now I will write. Before going to that, let me explain. In a parallelogram, diagonals bisect each other. That we know already. You write down parallelogram, diagonals bisect each other. That means, therefore, BM is equal to DM. Therefore, BM is equal to DM. Also, AM is equal to MC. Right? AM is equal to MC. Now consider this triangle. What I told just now, Apollonius theorem, what does it state? The sum of squares of the sides of a triangle is equal to twice the square of the median plus twice the square of half the third side of the base. Twice the square of half the third side of the base. That means AB square plus BC square is equal to AB square plus BC square is equal to 2 times BM square plus 2 times what I said just now, 2 times half the third side of the square of the third side, 2 times AM square. Right? Similarly, this is what Apollonius theorem states. Now similarly, AD square plus CD square. Similarly, AD square plus CD square is equal to twice the square of the median. Now this becomes the median. DM square plus twice the square of the third side. Now CM square. Right? Now what can you say? Here you can add all this AB, BC, CD like that. AB square plus BC square plus CD square plus AD square is equal to twice. Here what you have written, BM, and here these conditions, add this. Can you add this? 2BM, 2AM. Now what you do is 2BM, write this as it is, 2BM square plus 2AM square plus 2DM square plus 2CM square. So from this what can you say? This side already we have proved. So 2 times DM, 2 times DM is nothing but DM length, how will you get? Half of BD, no? Half of BD. Right? So 2 here DM, what I am saying is DM length in place of DM, already it is there. Oh, I am sorry. Here DM plus DM is nothing but 4DM square plus again what you do is, here AM is there, no? Here AD square plus CD square is equal to twice this one plus twice, again take same thing, AM square. Right? So now I have added these two. DM, here MB is there, MB square plus DM square. Right? So MB, here first what I have applied is clear. AB square plus BC square is equal to BM square plus AM square, twice BM square plus AM square. Now consider this triangle. AB square plus CD square is equal to DM square twice DM square plus twice the square of half the third side plus 2 times AM square. Now 2 times AM square plus 2 times, I have told to add these two, no? 2 times AM square plus 2 times AM square is 4 times AM square plus 2 plus 2 is 4. Now 2 times BM square plus 2 times BM square plus 2 times DM square. BM square plus 2 times DM square. So BM plus DM is nothing but what can you say here? 4AM square. AM is nothing but 4 AM is nothing but half of AC, right? AM, how will get this AM? Half of AC plus here BM and DM is given. BM and here BM and DM is given. So BM is nothing but half of BD plus 2 into DM. DM is nothing but DM length is how will get half of BD. So just we are near to the problem. So this is nothing but 4 into this is 1 by 4th AC square. 4 will get cancelled. Next here 2 into what will get 1 by 4th BD square plus 2 into 1 by 4th BD square, right? So AC square is equal to, now this one 2 ones are 2 2s are 2 ones are 2 2s are, right? Half of BD square plus half of BD square, right? So AC square is equal to half plus half BD square is nothing but BD square. Half plus half is 1. So very simple. I applied Apollonius theorem for this triangle and for this triangle. I applied Apollonius theorem for this triangle and this triangle. So AB square plus BC square is equal to twice BM square plus twice the square of the base of the third side. So 2 times AM square, like this. Next, come back to similarly we are considering this triangle. So state syllabus, I think they have removed from your syllabus by the Apollonius theorem. So it may be there for Cbse. 2 times AD square, again AD square plus CD square is equal to 2 times what? DM square plus AM square. DM square plus AM square. Right? Now we have to, I told to add these two. 2 AM square plus 2AM square is nothing but 4 AM square. This is over. Now here 2 BM square plus 2 DM square. This 2 BM square plus 2 DM. BM and DM. BM length how will you get? Half of BD. Half of BD. Next DM length how will you get? Half of BD. So therefore here 2 is already outside. So 1 by 4th will come. 1 by 4 will come. 2 gets cancelled. Half of is nothing but 1 BD square. So AC square plus BD square. This is one of the important problem which is lengthy, but if you apply Apollonius theorem, it is very easy. Thank you students. Have a nice day. We'll meet you in the next class. Don't forget to subscribe my channel. Click on the blue color icon button and share this with your friends. Bye. Have a nice weekend. Bye.